Good day, students. Welcome to Mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 11 to 15 of the Geometry Common Core New York Regents exam for June 2016. All right, let's take a look at question number 11. It reads, a 20-foot support post leans against a wall, making a 70-degree angle with the ground. To the nearest tenth of a foot, how far up the wall will the support post reach? Now, there's a tip I would like to share with you all about triangle problems presented in text format. Now, whenever you are given a triangle problem presented in text format, if you're trying to find the length of a side, the area, or the value of an angle, it's always beneficial to give yourself a visual. Okay, so when you have a visual, it's easy for you to sketch it correctly and also label it appropriately. So what we're going to do is we're going to create a visual of the situation that's happening right here. Okay, so we have a wall and we have a ladder that's resting on the wall. Okay, so say no, a support post, not a ladder. So it's 20 foot. The 20-foot support post leaning on the wall, and it makes a 70-degree angle with the ground. So this is going to be 70 degrees, and this right here is going to be 20 feet. That's how long the post is. Alright, the question, to the nearest tenth of a foot, how far up the wall would the support post reach? So we're basically looking for this length right here. Let's call it x. Okay? Alright, so now we have two sides and an angle. Now, anytime you're solving right triangles, of course, this wall is perpendicular to the ground. Anytime you're solving right triangles involving two sides and an angle, you're going to have to use right triangle trig. What am I talking about? SOHCAHTOA. Okay? SOHCAHTOA has three trig functions. We are going to select one to use to solve this scenario. Now, what are we using for this problem? Are we using sine, cosine, or tangent? So to enable us to determine the right trig function to use, we're going to label this triangle, take a look at what we know and what we need, and then we can determine the right ratio to implement. This is the angle that we have right here. This is a 70-degree angle. If this is a reference angle under consideration, that automatically means that the side opposite the angle is going to be called your opposite. Okay? Opposite the O in SOHCAHTOA. The side opposite the 90 degrees of any right triangle is always the hypotenuse, the longest side of the triangle. Okay? So we know the hypotenuse. We need to find the opposite. The adjacent plays no role in this problem. We don't need it. We don't know it, so we scrap it. Okay? So we're going to be using the trig ratio that has O and H in it. Sine, cosine, or tangent, which one are we using? We're going to be using sine. Alright? So the formula here is sine theta. Why are we using sine? Because it's the one that has O and H in it. Sine theta is opposite divided by hypotenuse. We'll substitute the known and unknown values into this equation and solve for x. Let's go ahead and do it. So we're going to go sine of the angle, which is 70 degrees, equals opposite x over hypotenuse, which is 20. To get x isolated, we multiply both sides by 20. Always put the number before the trig function, not after. Okay, so you don't make grouping errors there. So x is going to be 20 sine 70. We're going to plug this into our calculator and then round our final results to one decimal place. Okay, so we have 20 sine 70, which is 18.793 18.7939 feet. We're rounding to one decimal place, okay, to the 10th place, which is the first decimal place behind the decimal point. So let's write down what our final answer is. um, X is going to be equal to 18 point. Now, since 9 is 5 or greater, we're going to round up. Okay, so you carry 1 to the 7, and then 18.8 feet. Now, if you look at your options right here, this problem is also assessing your ability to accurately round. So if you didn't round it correctly by rounding up, let's say you truncated the decimal values behind the 7, basically rounding down, you get option 3, which is incorrect. So you have to be careful, all right? The correct answer for this problem is option number 4, 18.8 feet. All right, let's take a look at question number 12. It reads, line segment NY has endpoints n, -11, 5, and y, 5, -7. What is the equation of the line perpendicular bisector of segment NY? Now, one thing you want to recall is that if two lines are perpendicular, then the slope of one is a negative or opposite reciprocal of the other. Okay? Now, there are a lot of steps involved in solving this problem, so I enumerated the steps here so you can keep track of the whole process as I go through it. All right. Step number 1, we're going to sketch the situation, give ourselves a visual so we have a concrete roadmap from the problem to the answer. Number 2, we're going to proceed to find the slope of the line that we're asked to write the equation of. Okay. After that, we're going to find the midpoint of the segment because that point is on the line that we're looking for the equation of. And then lastly, we're going to combine the slope that we found and the point that we found in writing down the equation of the line that bisects the segment using the point-slope form of the equation of a line. Y minus y1 equals mx minus x1. All right? So let's go ahead and start by sketching the situation. So let's start by sketching segment NY. This is not to scale by any means. So let's go. Okay. So let's say that's segment NY. So this right here is Y. Y, as you can see, is a positive x going to the, wait, let me switch that around. I got it reversed. This should be n, the point that's on the second quadrant. Doesn't really matter how you sketch it though. So this is n, which is -11, 5, and then this point at this end right here is y, which is 5, -7 in the fourth quadrant. Okay, so this is segment NY. What are we looking for in this problem? We're looking for the equation of the line that bisects this segment. So let's say this is the midpoint here. This is M, midpoint. Okay, let's call it x1, y1. Okay, we're looking for the equation of the line that is a bisector of this segment and is perpendicular to the segment also. Okay, so let's just sketch something like that. And let's color it blue. Okay, so the problem is asking us to write down the equation of this line. Equation. Question mark, we don't know what it is. This line does two things. It bisects the segment and is also perpendicular. Okay? Alright, so we have step 1 accomplished. We have sketched the situation. What do we do next? We're going to find the slope of this line. So I didn't even label the line. So this is line L. Okay? Line L. We want to find the slope of this line. Okay, let's see, how do we do that? So we're going to find the slope M of L. So the formula for finding the slope of a line, I'm going to be organizing my formulas down here. Formula number one is slope m is equal to y2 minus y1 over x2 minus x1. Okay, so we're going to be using point N and point Y. So let's call this one x1 for the purposes of the slope. Okay, y1 and x2, y2. So the slope of ny, segment ny, is going to be, we're still going to use the formula y2 minus y1 over x2 minus x1. Alright, so you might wonder what is going on here. We're supposed to find the slope of L. Why are we looking for the slope of something else? Well, since this segment is perpendicular to this line, we can use the slope of the segment to find the slope of this line. Okay, so that's why I'm going off in a different direction first. Now let's find the slope of segment NY. Y2 minus Y1 over X2 minus X1. Okay, so you have negative 12 over plus plus slash and dash 5 plus 11 is 16. Okay, this can be reduced. Divide top and bottom by the GCF, which is 4. Divide by 4, divide by 4. And then you end up with the slope of the segment as negative 3 over 4. Okay? Now, since segment NY is perpendicular to L, what does that mean? It means that the slope of L is going to be the opposite reciprocal of this right here. It's going to be 4 over 3. The negative reciprocal of negative 3/4. This is the condition when two lines are perpendicular. Okay? Perfect. We have step 2 done, the determination of the slope of this line. Okay, before we proceed to step number 3, let me just write down the formula I used for step 2 here real quick. So the formula is as follows. If line 1 is perpendicular to line 2, then that follows that the slope of line 1 is going to be the negative reciprocal of the slope of line 2. Okay? Alright, now let's go on to step 3. We're to find the midpoint M of NY, because in order to write down the equation of a line, you need a point and a slope. Okay? We already found the slope here of L. We need a point on L since L goes through the midpoint of NY. The midpoint of NY is going to be a point that's on L too. Okay? So how do we find the midpoint? Let's write down the formula for that. And then use it to find the midpoint. So to find the midpoint, what you're basically doing is you're just averaging your x's and your y's. Okay, so you go x1 plus x2 over 2. You average your x coordinates, and then the same with your y coordinates. y1 plus y2, I'm running out of space here, over 2. Bam, that goes your midpoint formula. Okay, all right, so we're going to be using the coordinates for x1, y1 that we put here to find the midpoint. Okay, so let's go ahead and do that. Find the midpoint. We're looking for the midpoint of segment NY. Okay, its connection with L is that's the point of intersection. That point is common to both line and segment. Alright, so midpoint, we have x1, x2, y1, y2. I would like to be careful here because I don't want to confuse my coordinates. So y2 is negative 7, x2 is 5, x1, y1, what is it? x1 is negative 11 and 5. Okay, negative 11 and 5. Okay, so we're good to go. Let's go ahead and find the midpoint of segment NY. using the midpoint formula. So we have x1 plus x2 over 2, average of the x's, y1 plus y2 over 2. Okay, so what do we have here? We have negative 11 plus 5 is negative 6 over 2, comma 5 plus times minus becomes a minus. 5 minus 7 is negative 2 over 2. So the midpoint is negative 3, comma negative 1. Perfect. So now we're going to write down the equation of find equation of L. Okay? So in order to do that, the last formula for this problem is the point slope form of the equation of a line, y minus y1 equals mx minus x1. The nice thing about this problem is that the options are presented in that format. They are presented in the point slope format. So we don't have to do any algebraic manipulations to transform it into the slope intercept form. Okay? So that's a nice, a convenient feature of this problem. All right, so let's go ahead and just write down what we already have the formula. We know we have a point on L. On L is what? Negative 3, negative 1, because that point is on both the segment and the line. Okay, and then the slope of L is, we already found that before, 4/3. So how do we finish the problem off? We just simply go, use this formula right here, right? Y minus y1. y1 is negative 1. Y minus y1 equals m, which is, what is m? 4/3 x minus x1, which is negative 3. Okay? Recall, this is y1. I'm sorry, this is x1, y1, and that's m right there. All right. So, and then we put it all together. Just one more step. We're going to have multiply this to y plus 1 equals 4/3. Minus times minus again is plus, x plus 3. Ladies and gentlemen, that is our final result. Y plus 1 equals 4/3 x plus 3. And that is option number 1. All right, let's take a look at question 13. It says triangle RST shown below. In that triangle, we have an altitude of SU that's drawn from RT at U. So this is the altitude right here. If SU is equal to H, UT is 12, RT is 42, which of the values of H will make triangle RST a right triangle with angle RST as a right angle? Okay, so for this problem, there are two ways of doing it. Okay, you can solve this problem using similar triangles, or you can solve this problem using something called the altitude rule. The faster method is the altitude rule, which I'll use in this problem, or you can also use similar triangles also. Now, since SU as the altitude drawn from this extended base RT, that automatically means that this angle is perpendicular. Okay? The altitude is always perpendicular to its extended base. Now, you're told that RT is 42. Okay? The entire length of the base of the bigger triangle, the biggest right triangle, is 42. Now, the shorter side measure is 12. So what is RU going to be? RU is going to be 30, right? Because RU is basically the entire base, RT minus UT. Okay, RT is 42. Subtract 12, you get 30. Okay, so that's the that's the base of this other right triangle. We have three right triangles here. Okay, so in order for this to be a right triangle, it also has to follow the altitude rule. Okay, so let me show you what the formula is first, and then you see how fast it is to do this problem using this process, okay? So the formula, let's say this is h and this is x and this is y. Guess what? The altitude rule tells you that the altitude is equal to the square root of the product of these two bases right here that the altitude divides. Basically, that's called the geometric mean, okay? So times root xy. That's the formula we're basically going to use to find h. So in this problem, you can see that x is 30, y is 12, h is unknown. So we're going to use this geometric mean or altitude rule to solve for h. So we have h equals the square root of 30 times, that's x, y, which is 12. All right. So 30 times 12 is 360. There goes your answer. But the options are presented in the reduced form of a radical. So we have to reduce 360, okay? So let's go ahead and do that. There are different ways to reduce radicals. I like to use prime factor decomposition because it eliminates room for errors, because some of us are not too good with identifying our perfect squares. Um, or we might just make errors, okay? But this is a method of avoiding mistakes. So I'm going to decompose 360 completely into a product of primes, and then I will group repeated primes into pairs and then extract them as roots, okay? Alright, so let's go ahead and do that. So 362 is a prime that goes into that. 2 goes into 360 180 times. You can divide it with your calculator. 2 goes there 90 times. 2 goes there 45 times. Okay, so now this is odd. 2 doesn't work anymore. Since it ends in 5, 5 definitely goes. 5 goes into 95. See, 9 times. And then 3 times 3. Okay, so this is the prime factor decomposition of 360. Since we're taking the square root, any factor that repeats itself, we group them together and you take the square roots, you end up with just one of them, okay? So you have 2 times 2. What is the square root of 2 times 2? Square root of 4, which is just 2, right? So this comes out as 2. This one is by itself, so leave it alone. These ones are, oh, look here. The 3 and a 3, they repeat. What is the square root of 3 times 3? Square root of 3 times 3 is 3. Okay, so 3 and 2 come out. 2 and 5 stay behind. The simplified form of root 360 is 6, which is, well, let me show you the steps so you don't get confused. So it's going to be 2 times 3 on the outside, these 2 that broke out, root the 2, this 2 that didn't come out, and this 5 that didn't come out either, which is equal to 6 rad 10. Okay, so that's what h is in simplified form. So h is equal to 6 rad 10. And your final answer is option number 2. Okay, let's take a look at number 14. It says in the diagram below, triangle ABC has vertices 4, 5, 2, 1, and 7, 3 for A, B, and C vertices respectively. Question, what is the slope of the altitude drawn from A to BC? So in this problem, you need to know how to draw your altitude, and you also need to know that the altitude is always perpendicular to the extended base or the base that it is drawn from. Okay, so in this problem, this is the extended base. This is the base that the altitude is drawn from. We're going to draw a perpendicular line from this base and intersects this point right here, point A. So if you want to draw it, it's going to look something like that. So that's your altitude. Okay. All right. Let's color it red and label it. So this is our altitude right here. Okay. Now let's call this point ABC. Let's call it D. The question is asking for the slope of AD. What is the slope of that segment? Okay. Now since AD is perpendicular to BC, what do we know? We know that the slope of two perpendicular lines, one has to be the negative reciprocal of the other. We already talked about that. So we find the slope of BC and do the opposite reciprocal, that would give us the slope of AD. Okay, so what I'm saying in essence is that the slope of AD is equal to the negative reciprocal of the slope of the base BC, because since AD is what? Perpendicular to the base BC. That's the basis, okay? So what's the missing piece here? We just need to find the slope of BC, and then we carry out this opposite reciprocation to get the slope of AD, okay? So let's do it. Let's find slope of BC. We already know what our slope formula is. In this problem, we can use rise over run, okay, if you want to save time. So let's do that. Graphical determination of the slope. We're going to use rise over run. If you don't like that, you can definitely use coordinate geometry. Just take the points and plug it into y2 minus y1 over x2 minus x1. Alright, so I'm trying to be lazy here. So I'm going to go rise 1, 2. That's my rise. Rise 2. And my run, wait, what did I just do? Okay, I'm rising to this point right here. And my run is 1, 2, 3, 4, 5. My run is 5. Okay, so we're going to rise 2. And this is our run right here. 1, 2, 3, 4, 5. And then we're going to run 5. Okay, alright, so rise over run is 2 over 5. So that follows that the slope of segment AD, the one that we're looking for, is going to be the opposite reciprocal of this. Let me show you the work. You can just flip it and negate it, but let me show you how it works because it's kind of cool. 2 over 5, like that. And then to reciprocate, you just multiply 1 by the reciprocal of the denominator, 5 over 2. And you end up with your final answer, negative 5 over 2. Your answer for problem number 14, let's see, is option number 4. Okay, let's take a look at question number 15. It says, in the diagram below, triangle ERM is similar to triangle JTM. So which statement is always true? Okay, so one reminder concerning similar triangles, we're talking about similarity here because that notation there indicates that the triangles are similar. So whenever you have two triangles that are similar, one thing that always happens is that corresponding angles are always congruent. Remember your AA or AAA similarity postulate. That's what we're going to be using to solve this problem. We're going to be using that, and then we will be using SOHCAHTOA also to help us out. Alright, now this problem involves applying the trig ratios to two triangles and also comparing corresponding angles and setting up ratios. So in order for you not to get confused, what I'm going to do is I'm going to separate the two triangles and I'm going to consider it case by case for each option that we have here. Okay, so let's extract triangle JTM, and then I'll extract triangle ERM. I'm going to make 4 cases, okay? Well, I'll start with 1, and then if that doesn't work, then we'll add more triangles as we go. Alright, so there goes the two triangles. I'm going to call this triangle 1 and then call this triangle 2. Okay, so we have JTM and we have RME. Now there's a quick way to do this problem, but the goal here is not just to rush through it. I just want to make sure you understand exactly what is going on in this problem. Okay, alright, so let's start with option 1. Cosine J, is it equal to Rm over Re? That's the question. So the trig function under consideration is cosine J. So we're looking at triangle number 1. So for triangle 1, that's J. Angle J, if that's angle J, that's going to be the opposite for triangle 1. Um, this is going to be the adjacent for triangle 1, and then this is the hypotenuse for triangle 1. Okay, all we actually need is just adjacent and opposite, right? So we're going to be using SOHCAHTOA to set up a trig ratio. SOHCAHTOA. Okay, so what do we have? Cosine J is going to be adjacent from triangle 1 divided by the hypotenuse from triangle 1, from K, okay? So adjacent is going to be JM divided by the hypotenuse, which is JT. That's not what we have here, but we also know that cosine J, angle J is congruent to angle J is congruent to what? Angle J is congruent to angle E. Okay, because they are corresponding angles. Okay, so that follows that cosine J is equal to what? Cosine E. Okay, so let's set up what cosine E is and then set it equal to cosine J and see if that's what option 1 is. Okay, so cosine E, now we are switching to triangle 2. Since we're doing cosine, just to save time, we're doing adjacent over hypotenuse, okay? So this is the adjacent for triangle 2, and this is the hypotenuse for triangle 2. So cosine E is going to be adjacent for triangle 2 divided by hypotenuse for triangle 2, which is EM over the hypotenuse, which is RE. Okay, so based on this fact, we can conclude that cosine J is equal to Jm over Jt and is also equal to Em over Re. Any of these ratios will work. So let's look at the option we have. It says Rm over Re. That was close, huh? This is R, that's E, so this is wrong. Option number 1 is wrong. Had it been that this way, Rm over Re, it will be correct. So this is wrong. Now let's take a look at the second option, 2. Alright, so we're going to do the same thing again. Test it to see if it's the statement that's given is true or false. So the statement is cosine R is equal to Jm over Jt. Is this true or false? That's the question. Okay, so we have J, M, T. We're using cosine again, so we're going to be using K, R, M, E. Let's call this triangle 1, triangle 2. Okay, now we're setting up cosine R. Oh, now we are starting from triangle 2. So from cosine R, we have using SOHCAHTOA. Cosine R is going to be adjacent of a hypotenuse. So for this triangle, this is going to be now relative to this angle. Okay, remember when you're using SOHCAHTOA as relative to your reference angle, so this becomes the adjacent, and this becomes your hypotenuse. Okay, adjacent to hypotenuse 2. So cosine R using this triangle is Rm divided by the hypotenuse, which is Re. Okay, that's not what we're looking at here. We're looking at using this, the cosine of this angle and the ratios from this triangle. But what do we know? We know that angle R is congruent to angle T because they are corresponding angles. So let's write that down. Angle R is congruent to angle T. So that means that, what does that mean? It means that cosine R is equal to cosine T. Okay, so let's go ahead and figure out what cosine T is in this problem. So cosine T, now we're switching to triangle 1. We're using K and SOHCAHTOA, so we just need the adjacent and the hypotenuse. This is the reference angle, so this is adjacent 1, hypotenuse 1. So cosine t is going to be adjacent over hypotenuse. So adjacent is Tm over the hypotenuse, which is JT. Okay? So we can say that cosine R is equal to Rm over Re using triangle 2, which is also equal to um, cosine t, which is equal to Jm over Jt using triangle 1. Remember, cosine R and cosine t are the same, so these ratios are equal also. So let's look at the option that we have over here. Oh, actually, I already messed it up. It's Tm, not Jm. Alright, so it's equal to Tm over Jt. Okay, so is this equal to the statement we have here? Cosine R is equal to Jm over Jt. Cosine R is Tm over Jt. So because of that T there and the J, guess what? Option 2 is incorrect. Okay, so let's move on to the next option. Okay, so let's look at number 3. So number 3, the question is tan, oh, we switched trig functions now, is tan t equals Rm over Em? That's the question. Okay, so let's see. Tan t, we're looking at triangle 1 now. Using SOHCAHTOA, we know that tan is opposite over adjacent. So tan t is going to be opposite for triangle 1 over adjacent for triangle 1. Let's write down what that is. So let's see here. This is the reference angle is t, right? So that means that this would be the opposite for triangle 1, and this side right here will be the adjacent for triangle 1. Okay, so tan t is going to be Jm over the adjacent, which is Tm. Okay, so the question is this true or false? We don't know yet. But we know that tan t is congruent to angle t is congruent to angle r because they're corresponding angles. They're congruent. All right, let's write that down. Angle t is congruent to angle r. So what does that mean? It means that tan t is going to be equal to tan r. Okay, because they are corresponding angles. Now let's figure out what tan r is. Tan r is going to be opposite over adjacent again, but with triangle 2. Okay, so this is the adjacent for triangle 2. This is the opposite for triangle 2 relative to angle r. So tan is going to be opposite over adjacent in triangle 2. Okay, which is going to be opposite is Em over the adjacent, which is Rm. Okay, so since these angles are congruent, we can easily state that tan t is equal to Jm over Tm, which is equal to Em over Rm, which is equal to tan r. Okay. Now, does this agree with the option we have here? So it says tan t is equal to Rm over Em. Tan t is equal to Em over Rm. This answer is wrong. We have the reciprocal. Okay, so it has to be Rm on top and Em on the bottom, but it got reciprocated here, which is incorrect. So by elimination, we know that the answer should be option number 4. Okay, but we're going to have to do it. We can just assume, and then so I can show you that the answer is in fact correct. Okay, so here we have it again. This is triangle 1, triangle 2. And then this question is this statement tan E equals Tm over Jm, is it true or false? Okay, so let's go ahead and set it up. Let's start with angle E. We're looking at triangle 2 this time. So relative to that triangle, we're dealing with tan from SOHCAHTOA, so we need the opposite. O2 and the adjacent of triangle 2. Okay, so tan E is going to be the opposite for triangle 2 divided by adjacent for triangle 2 from TOA. Alright, so O2 is RM over A2. The adjacent for the second triangle is EM. Okay, but we also know what? What do we know? We know that angle E corresponds to angle J. Since they're similar, corresponding angles are congruent. So angle E is congruent to angle J. Okay? What does that mean? Well, it follows that tan of E is equal to tan of J since the angles are congruent. Okay? Now, let's write down some trig ratio for tan of the corresponding angle J. Okay? So tan of J using triangle 1 this time, because J is in triangle 1, is opposite. The opposite for triangle 1 over the adjacent for triangle 1. Let's go ahead and label it here. Since this is the reference angle, the side opposite it is opposite for triangle 1. This is the hypotenuse, this is the adjacent for triangle 1. We're just using opposite and adjacent because of TOA and SOHCAHTOA, okay? Alright, so we have that. Let's put in the side measures. Opposite for triangle 1 is TM right here, and then the adjacent is JM. Okay, let's write down some equations. So tan of E in the big triangle is RM over EM, and it's also equal to TM over JM and the second triangle. Why? Because tan of E is equal to tan of J. Okay, so is this statement tan E equals TM over JM correct? Tan E is equal to TM over JM. Voila, there goes your correct answer. So this statement is true, whereas the other ones are false. Okay, so we can clearly see that the answer is option number 4. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial beneficial to you, please give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe for updates to the remainder of this review series. And if you have any questions or comments, just place it in the comment section below and we'll be glad to support you. More clips can be found on Mathgotserved.com. Thanks again for watching and have a wonderful day.